In example B here, we have exactly the same sort of a process we had in example A. We just have two variables together in the same problem. So what we'll do is apply our same rules. We'll do x to the fifth divided by x to the third, which means we need to subtract 5 minus 3. That gives us x to the second. And then we have y to the third divided by y to the second. So we're going to divide or subtract 3 minus 2. It gives us y to the first, or just y. So x squared y is the answer. Okay, example C here, we have a slight change, and that is we can see when we start to apply our rule for dividing powers here that when we subtract, we get 2 minus 6, which is a negative number. We end up with x to the negative fourth power, which seems a little odd. And it would be natural to sort of think that, oh, that must just be the same as negative x to the fourth power. But that's not really true. If we were to look at this problem again in longhand, then x to the second over x to the sixth would look like this. Xx over, and then 6 of them, 3, 4, 5, 6. And then when we canceled, we'd end up taking away 2 from the bottom and all from the top, leaving a 1 on top, but 4 x's left on the bottom. So that could be written as 1 over x to the fourth, x to the fourth power. So since this problem could be written this way, and this, when it's canceled this way, we end up with 1 over x to the fourth, or this problem could be read the way it was originally written, using our subtraction rule, and we end up with x to the negative 4. That must tell us that x to the negative 4 is the same thing as 1 over x to the positive 4. And that's true. Whenever you have a negative power on one side of a fraction bar, say on top, it's the same as having a positive power on the other side of the fraction bar. So x to the negative third is the same thing as 1 over x to the positive third, and 1 over x to the negative sixth is the same as x to the positive sixth over 1, if you'd like to think of it that way. So then for our second example here, we have, divide that off there so we can make sure it's not the same thing. We have a to the second over a to the fifth. That would give us a to the negative third, and b to the sixth over b would give us b to the fifth. So this is one answer, but the problem specifically asks us to write the answers with positive exponents. So we're going to take our a to the negative third and move it down under a fraction bar, giving us b to the fifth over a to the positive third. A negative power on one side of a fraction bar is the same as a positive power on the other side.